So that leads us to the fundamental theorem of algebra. A polynomial of degree n has n complex roots, counted with multiplicity, of course. How many roots? Oh, yeah, remember that complex numbers also include real numbers. So whether it's real, imaginary, or complex, we count all those, and that will equal the degree of that polynomial. How many roots do the following polynomial equations have? Well, we just basically just say what degree they have. So this one has 5 roots because it's a degree of 5. This one has 1, 2, 3, and then another 4 would be 7. Okay, and then this one, this is in factored form, so of course we count it up like I just showed. This one's in standard form, we use the highest exponent. This one's in standard form, so we just use the highest exponent, 11 roots. Okay, and then the next couple problems are just a combination here. We're just going to say how many roots they have and then actually find the roots. So number 9, we're asked to say how many roots we can expect here and then find all the roots. And yeah, if the multiplicity is greater than 1, we should state that. So we know we're going to have 3 roots because the degree of this is 3. So let's find that. This is the first one we're encountering where we have to factor by grouping on this note sheet. So I want to take out the biggest thing I can out of this first pair and the second pair. So the first pair, 2x squared could come out of both of those. 2x squared times x would be 2x to the third. 2x squared times negative 6 would be negative 12x squared. Out of these two, 34, I believe, goes into 204, but let me double check that. 204 divided by 34, how about that? It does. So we take out 34, x, I think a negative 30, or sorry, not x, just negative 34. Let's see if this works out. Negative 34 times x would be negative 34x. Negative 4 times, again, 6 would give us negative 6. We have to make it negative because a negative times a negative would give us a positive, right? So that worked out. These match. So now we can rewrite this as x minus 6 times 2x squared minus 34 equals 0. And now we can solve this. Either x minus 6 equals 0 or 2x squared minus 34 equals 0. And then we solve both of these just like we've been doing. This would be x equals 6, right? So that's one of the solutions here. We got to do a little bit more work. We're going to add 34 to both sides. 2x squared equals 34. Divide by 2. We get 17. Take the square root. So x equals positive or negative square root of 17. Can't reduce that at all. So our solutions or roots are negative square root of 17. The positive square root of 17 and 6. So notice we got 3 roots. You guys go ahead and do the your turn. Okay, here's what I got for my answer here. So I have a total of, I forgot to write the first thing. There are a total of 6 roots, right, because of the x to the 6th. The degree is 6. And yes, I got 2, 4, 5, 6 roots. Notice you did have some multiplicity in this problem. When I factored here, I did factor by grouping. One of my factors was x to the 4th minus 9. That is a difference of squares, so that breaks down into these two factors, which this factor happened to be the same as this one, so they can be grouped together. And you could write it as x squared minus 3, that whole thing squared. And then I just went off and used the zero product property, set them both equal to 0, found out what x would have to equal to make them 0. And for this first factor, it was positive or negative square root of 3. For this one, it was positive or negative I times the square root of 3. Yeah, this has a multiplicity of 2. Both these answers here have multiplicity 2 because of the 2 here. All right, there's basically 2 of these, so these answers are doubled. All right, so that is my answer there. Okay, let's look at number 10 here. First, I want to see if there's something in common I can take out of these. Yep, x to the third. And x to the third times x to the fourth is x to the seventh plus 15. And I need two more x's. 3 plus 2 gives us 5, right, on the exponent. So 15x squared. And then x to the third times 56 would give us 56x to the third. Then I'm going to try to factor this this way. Two numbers that multiply to 56 and add to 15. Yep, that would be 7 and 8. And so this breaks down into x squared plus 7 and x squared plus 8. So one of our answers is 0, because if this were 0, the whole thing becomes 0. But now notice it has an exponent of 3. So that has multiplicity 3. All right. And then x squared plus 7 equals 0. We take away 7 on both sides. We get x squared equals negative 7. Take the square root. X equals positive or negative I root 7. Okay, and then the other possibility is x squared plus 8 equals 0. Take away 8 on both sides. We get x squared equals negative 8 square root. X equals positive or negative I root 8. 8 also, square root of 8 can break down to the square root of 4 times the square root of 2. So that's going to be 2 root 2. So we'll have positive or negative 2i times the square root of 2. So our answers are, all of our roots here are 0, multiplicity 3. And then we have, I'm going to go ahead and just write them together here. Positive or negative I root 7, positive negative 2i root 2. So we have a total of 1, 2, 3, 4, 5, 6, 7, right? And I actually forgot to do that here too. Our roots, we have 7, right? Because of the degree is 7. And that matches here. 1, 2, 3. This counts as 2 because it's positive or negative. 4, 5. And this also counts as 2. 6, 7. All right, you guys do the your turn. So what I got for my answer was right here. I factored this. It's a trinomial, and 8 times 8 equaled 64. 8 plus 8 equals 16. Broke it down like this. And it was the same factor twice, so that's why it's squared here. Then this was a difference of, or sorry, a sum of cubes. So that was the formula for that. And my a was x, my b was 2. And so this broke down into these two factors. And of course, that whole thing is squared. Rewrote it like this. It's a little less confusing than this. And then I just found out what made each factor equal to 0. And since both those factors were squared, that means both of the roots I came up with would have multiplicity 2. Or I should say each of the roots I came up with. This one, of course, had 2 individual roots because the plus or minus, I had to use the quadratic formula. So I had a total of 6 roots here. All right, 2, 4, 6.